We are going to take today a little bit easy because we're still kind of easing into physical science and what doing this online is going to be like. So this is my first time teaching this like this online, and so this first day hopefully we'll kind of see how things work. So you should be keeping track of what you need to be doing. By Friday, I would like you to have finished this video. This will be fairly short. Begin reading the next chapter on the online textbook. Make sure that you have your Top At account set up and ready to go. Remember, you have a free 2-week trial in order to get your user codes and everything set up and ready to go. Make sure you keep track of what's coming up and what's due on Moodle, so that should be nice and clear. There are a few short assignments on Moodle. They're very simple. They're just a way to get us some points in the grade book so that we start off on the right foot. Okay, the Chapter 1 textbook reading gives you a good introduction to this material. There are some podcasts in there, some other interesting things that kind of give you an idea of what the scientific method is. So the scientific method is the general way that science is done. It is a way that helps us as scientists to ensure that our findings are accurate, that they can be replicated. The scientific method is used in making sure that the car you drive is safe, and make sure that the vaccine that you take is safe and that it works. The scientific method is used in so many aspects of your life, but it all starts with the first part is to make an observation. So to observe means to closely notice the world around you. So the world around you could be the dorm room where you're sitting. It could be when you're in lab, a beaker of a liquid that's sitting in front of you. It could be when you are at the beach observing the ocean waves crashing. Whenever you use your senses to notice what's going around you, you are observing. So I want you to choose one thing in the room where you are and observe it for a short time. You can observe things like, what color is it? Is it moving? If it's moving, how is it moving? Is it moving towards something or away, or is it sitting in a desk observing something else? Does it require a motor? Does it have a light? Does it have a switch? Does it have a battery? All of those things are observations. So part of observing then is to recognize a question or a puzzle, such as an unexplained observation. If you look in your room at your fan sitting on your desk and it's smoking, a good question would be, why is my fan smoking? That's not a normal thing. It's an unexplained observation. After you observe, sometimes an observation takes 10 seconds, sometimes an observation takes years. You come up with a question. So a good scientific question is followed by making an educated guess, otherwise known as a hypothesis, to form a plausible answer to your question. So if your item in question was a white wall in this room, or the room where you are, you might hypothesize that the wall is white because it is covered in paint that uses titanium as a pigment. Or maybe your hypothesis was a little more simple than that. If your item in question was the person sitting next to you, or the person that you're hearing through this recording, but if you observe a person fidgeting at their desk, you might hypothesize that that person is hungry for an afternoon snack. That's probably maybe a little bit more like your hypothesis, but it's a good guess of a possible explanation for a behavior that you observe. After we make a hypothesis, we then make predictions about how our hypothesis will turn out, how our educated guess will turn out, and then we test them with experiments. So with your experiments, you want to predict the consequences that can be observed if the hypothesis is correct. The consequences should be absent if the hypothesis is not correct. So, ways we could test these observations we made earlier in our hypotheses. The white paint could be tested to determine if it includes metal atoms with a mass of 48 grams per mole, which is the molar mass of titanium from the periodic table. Maybe that's a little too much chemistry for you guys at this point, but maybe our second observation and hypothesis would be easier. The student in the back who can't sit still during class could be given a snack and observed to see if they can focus more easily with a full stomach. So again, our experiment is designed to test the hypothesis and to see if there's a correlation between the student being hungry and how they can't sit still. The last part, or as we wrap up the scientific method, we need to draw a conclusion. So we need to formulate the simplest general rule that organizes our observation, our hypothesis, the predicted outcome of testing our hypothesis, and then what the experimental findings are. So when we tested it, what actually happened. So some conclusions from our hypotheses we made. We could say that white paint likely contains titanium as a pigment. Another conclusion could be that hunger can cause restlessness in students. Probably the second one is a little more familiar to you, but it's still, both are still valid conclusions.